Good morning, dear distinguished guests, including my lecturers, my colleagues. Today I am going to present about serosurveillance of antibodies for Amplasma marginale in cattle from a dry herd in Videgama Dairy Farm, Hambantota. First of all, I would like to give a brief introduction about bovine anaplasmosis. Bovine anaplasmosis is an infectious but non-contagious disease which is caused by intraerythrocytic parasite Anaplasma marginale, which causes severe economic losses in both dairy and beef industry. The disease transmission mainly occurs through mechanical and biological modes of transmission. The mechanical transmission methods includes the blood-contaminated fomites, which includes the ear tagging equipments, the castration instruments, and tattooing instruments, etc., while biological transmission mainly occurs via ticks. The clinical signs of bovine anaplasmosis are mainly attributed to anemia, jaundice, and sudden death. In addition to that, the fever, loss of appetite, and loss of condition is mainly encountered in animals with bovine anaplasmosis. Cattle of any age is susceptible to the infection, but the severity increases with the age. Once the animal get infected, they remain persistently infected, and those carrier cattle have lifelong immunity and they are resistant to the infection. And if we talk about the disease history of the Videgama farm of anaplasmosis, in December 2016, about 100 cattle which were in pasture as dry cows showed clinical signs which are similar to anaplasmosis. And similarly, in 2017 and 2018, the reoccurrence of the disease with significant mortality and morbidity was recorded. And similarly, in 2019 May, 4 animals of the dry herd in their mid-gestation period were reported with sudden death. And the blood smears of those dead animals were positive for Anaplasma species. The objective of this study is the determination of Anaplasma marginale specific antibody in a dry herd at a Videgama farm, Sri Lanka. In materials and methods, first we did the collection of samples. It was done using free grazing dry herd consisted of 100 animals. Out of those 100 animals, 50 animals were randomly selected and the blood samples were collected from those animals and they were transported to the VRI. And then at the VRI, serum separation was done. This was done by centrifugation of samples at 2500 rpm at 24 degrees Celsius for 10 minutes. And next, the detection of antibodies for Anaplasma marginale was done by using ELISA kit. This procedure is based on solid phase indirect ELISA, and the whole procedure is carried out according to manufacturer's protocol. And this is the ELISA plate, and this is the procedure that we carried out. And next, the presence of antibodies for Anaplasma marginale was determined with the PP values. The PP values which are above or equal to 25 was considered as the animals are positive for antibodies against Anaplasma marginale, while the PP values below 25 are considered as negative samples which are not present of antibodies for Anaplasma marginale. And this is the ELISA plate. And next, we prepared a serial dilution for all the positive samples. And doublet dilution is the method that we use for positive samples. And each successive tube was half the amount of the original concentrated solution. And 1:40 dilution was prepared by adding 200 microliters of pre-diluted sample to 200 microliters of PBS screen buffer. And here is a schematic diagram of the serial dilution that we did. And this is the plate of the serial dilution series. And here these tables represents the results of the 47 animals, and this table summarizes the mean OD values, the PP values. And here the animals that are positive for the antibodies against Anaplasma marginale was based on the PP values which are above or equal to 25, while the PP values below 25 was considered as animals which are negative for antibodies against Anaplasma marginale. And next, those PP values were correlated with the parity and the breed of the animal separately. Here, the parity of the animal was correlated with the PP values, and it shows there was a significant uh, where the parity plays a significant role in development of antibodies against Anaplasma marginale, while breed does not show a significant factor for the development of antibodies against Anaplasma marginale in the herd. And these tables represents the serial dilution that we took place for positive samples. And this table summarizes the serial dilutions for those positive samples. And in conclusion, 19%, that is 9 out of 47 animals of the free grazing herd were detected with antibodies for Anaplasma marginale. The 19% is far below the amount of the herd immunity, which is considered as 80%. So, this amount of immunity will not protect the herd from subsequent infection. Therefore, proper tick control methods is very essential for the control of the infection in the farm. And even though very high antibody existence was expected due to regular infections at the farm, it was not observed. Here with the results that we analyzed, it shows that parity play a major role in developing antibodies against Anaplasma marginale, whereas breed does not play a major role. And in future directions, presence of carrier animals in the next generation should be analyzed by serological diagnosis, and also it would be beneficial if the serological analysis can be conducted in the farm to screen all the animals. And also in-depth investigation on abortion and reproductive diseases of the farm is very essential. These factors will play a major role in controlling the infection of the farm, and also this will also reduce the economic losses that causes to the farm by this bovine anaplasmosis condition. And also the development of vaccine, which will be a very important factor that can be done if the study is further extended and the whole farm is screened with the ELISA method. And I would like to thank these people for making my study a success. And here are the references, and thank you very much.